Chapter 5, Section 1 is about perpendicular angles and bisectors. Equidistance means two things that are the same distance. So equidistant, the same distance, or equal distances. Perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. So you'll notice right here, this point is on the perpendicular bisector. Then that means that XA is congruent to XB. And the reverse of that is true, the converse of the perpendicular bisector theorem. If a point is equidistant from the endpoints of a segment, then it is the perpendicular bisector. So here we have XA congruent to XB, and we can conclude that we have a perpendicular and also a bisector. And the next definition is locus. A locus is a set of points. A set of points that satisfies a condition. Set of points that satisfies a condition. So for example 1, you will see we have a perpendicular bisector here, and we are trying to find the length of YW. Since this is the perpendicular bisector, these two segments will be the same distance, so that will also be 7.3. Letter B, these two segments are the same distance. That means this is bisected, so this piece is also 16. But be careful, we weren't asked to find BD, we were asked to find BC, which is the whole thing, and that will be 32. 16 plus 16 is 32. In our third example, we have a little bit of algebra thrown in here. We have perpendicular bisectors. That means these two things are equal. 2n plus 9 equals 7n minus 18. From there, you subtract 2n from both sides, and you end up with 9 equals 5n minus 18. And if you add 18 to both sides, you end up with 27 equals 5n. And from there, you divide both sides by 5, and you end up with n equals 5.4. Now we were asked to find PR. So 2 times 5.4 is 10.8, plus 9 is 19.8. Example 2, L is the perpendicular bisector. So that means segment DG is congruent to segment GE. EG is 14.6. That means DG will also be 14.6. And example 3, DE, this whole segment here, is 20.8. DG is 36.4, and GE is 36.4. That means this is the perpendicular bisector. So to find EF, we are going to do 20.8 divided by 2, and each of those pieces will be 10.4. The top of the next page angle bisector theorem. If a point is on the bisector of an angle, so that means this angle right here, angle APB, is cut in half or bisected, then it is the same distance from the sides, so those distances are congruent. AC is congruent to BC. And the reverse of that is true if a point in the interior of an angle is equidistant from the sides of an angle. So if these two things are equal, and you'll notice it's the perpendicular distance, then you can say the angles are going to be equal. So the first thing we are asked to find is LM. Since these angles are equal, these segments are equal, and LM will be 12.8. Example B, since these segments are equal, we know that these angles are equal. This whole angle is 112 degrees. So to figure out how big ABD is, we would divide that by 2. Alright, I'm going to use my calculator just to be sure. And that angle is 56 degrees. Since the sides are equal, these angles are equal. Letter C, we are asked to find angle TSU. Since these sides are equal, these angles are equal. And this one involves a little algebra. 5z plus 23 equals 6z plus 14. From there, you subtract 5z from both sides, and you have 23 equals z plus 14, and subtracting 14 from both sides, 23 minus 14 is 9. So z equals 9. And now to figure out angle TSU, we are going to do 5 times 9, which is 45, plus 23 is 68. So that angle is 68, and that actually, both of those angles, TSU and RSU, would both be 68. Letter D, YW bisects, so that means these two angles are congruent. WZ is 3.05, so WX would also be 3.05. Example E, WYZ is 63 degrees. XW is 5.7 and ZW is 5.7. Since these sides are equal, these angles are equal. Now be careful on this one. You were asked to find angle XYZ, and for that one you have to do 63 plus 63, which is 126 degrees. And a couple more examples. Each pair of suspension lines on the parachute are the same length. Each pair of suspension lines on a parachute are the same length and equally spaced from the center of the chute. So these two things are equal. How do these lines keep the skydiver centered under the parachute? Well, since these two are equal, we know that this one is the perpendicular bisector, And since that is the perpendicular bisector, then it would be centered. Example 6, write an equation in point-slope form. Just a reminder, point-slope form is y minus y equals m times x minus x. And we want the perpendicular bisector of this. So, first of all, we need to find the bisector of those 2 points. And the bisector is the same as the midpoint. So -1 plus 3 over 2 and 6 plus 4 over 2. -1 plus 3 is 2, divided by 2 is 1, and 6 plus 4 is 10, divided by 2 is 5. So this is our midpoint that we're going to put in here. And now we want perpendicular. To find perpendicular, we need to find the slope of a line. Slope formula is y minus y over x minus x. So for our slope, I am going to do 6 minus 4 over -1 minus 3, which is 2 over -4, and our slope is -1/2. That is the slope of this line, and we need to find a new perpendicular slope, and the new perpendicular slope is the negative reciprocal, so it will become a positive, and the reciprocal is 2. Now we put this slope in for m, this point in for x and y, and our line will be y minus 5 equals 2 times x minus 1. And example 7, write an equation in slope-intercept form for the perpendicular bisector of the segment with these endpoints. And we have to do all this work, and then we have to solve for y. So first of all, we have to find our midpoint. Let's do that first. Midpoint is x plus x over 2 and y plus y over 2. 5 plus 1 is 6, divided by 2 is 3. 2 plus -4 is -2, divided by 2 is a -1. So that is our midpoint. And now we have to find the slope. Slope formula is y minus y over x minus x. So we will have 2 minus -4 and 5 minus 1, which becomes 6 over 4, which is 3/2. So we have our point and our slope. We're going to put that point slope into this form. So that will be y plus 1 equals 3/2 x minus 3. And distributing, that becomes y plus 1 equals 3/2 x minus 9/2. And I'm going to rewrite that using decimals. 1.5x minus 4.5, and then you subtract 1 from both sides and you have y equals 1.5x minus 5.5.